Hello all my JavaScript friends, this is the Virtuoid, aka Mike Smith, and this is Fun with JavaScript, our Jigsaw Puzzle game. Yeah, it's been about a couple of weeks since I last posted a video. I've got other things in my life that I am doing, and they are a lot of fun, but they take up hours upon hours of time at night, and I'm just too tired to do anything. But I've caught a couple of breaks, and so let's get to our next section. And in this section, we're going to be working with the unit test for our puzzle, our piece, and our vertex objects. So just to recap, a puzzle is made up of an entire puzzle, as you can see there upon the screen. Each puzzle is made up of different pieces, and each piece is made up of different vertices. And the idea here basically is that when you have two pieces close together, we compare the vertices for each of those pieces. If at least two vertices match, then we have a connection between two other pieces, and they are considered connected. At that point, we would combine those two pieces into one piece without the vertices, and we just continue on and on and on until we get one final piece. When we're down to one piece, the puzzle is created. So what we're going to do here today is we're going to create the unit test that will cover the puzzle, the pieces, and the vertices. So let's get to it. All right, so the first thing we're going to do is let's take a look at our vertices. So we're going to create a new JavaScript file and call that one vertex.cy. And do I want to add the file to Git? Of course I do. What do you mean I would want to add the file? Of course I want to add the file. What do you expect? Anyway, so let's take a look at that vertex. And vertices are going to be extraordinarily simple to do. Let's throw the code up there. Okay, and that's pretty much it. We should not be able to add a property. Because if you remember within our README that we did last time, we wanted to be able to say that there should exist a vertex that contains a unique identifier and is immutable. Now the fact of the matter is that as I was working with this puzzle, I realized that the vertex itself would be its own unique identifier. So really there is no need for this section at all. Oops, let's try that again. So there's no need for this section at all. And as a matter of fact, there really is no need for this section for the piece because it itself can be its own immutable, its own unique identifier. And puzzles, I don't think we have to worry about that. So basically, we've just got rid of two more pieces to the puzzle, to use the term, that we don't have to worry about. So the only thing we got to worry about here is that our vertex must be immutable. What that vertex contains, I don't know. Now, as we continue on, as we get the graphical parts of this, we may be adding a graphical part to the vertex. In that case, there will be some more properties, but this being the non-graphical part of our vertex, we don't need to worry about that. So we just have to worry about it being immutable. So let's go ahead and let's write that test. And that test happens to be that we should not be able to add a property, which means we should not be able to add a property, basically. So let's go ahead and type in that test. And here we go with the test itself here. I added a identifier here. I really don't need to do that at all now. So let's take that out. And we're going to basically try to add a property. And if we are able to add a property, we're going to immediately do an assertion error. Otherwise, we should be able to get a type error on our vertex. So we're also going to need to be able to create our vertex source code. So let's go ahead and create a new directory. Here's our source. And let's create our new JavaScript file, which will be vertex. Actually, sorry. I want to create a new JavaScript file because I want to be able to, I want to create a new JavaScript directory. And within the JavaScript directory, I'm going to create a classes directory. Okay. And within classes, now we're going to do a new JavaScript file. We're going to call it vertex. And we're going to say export. And we're going to get our fingers correctly on the keyboard. We're going to say export default class vertex. And we're done. So we're cool. That should run now because we've now got our import from our vertex class. And that's all we really need to do. That's going to basically allow us to do the immutable property or be able to basically say, hey, is this particular vertex immutable? So why are we not changing a property? Because we have no properties to change at this particular point in time. And so that will that will basically finish off our unit test for the vertex. So for the piece, is basically we got a couple of things. It's going to have to contain an array of vertices. It must contain at least one vertex, and it itself must be immutable. So let's go ahead and let's create in our E2E section of Cypress. Let's go ahead and create new JavaScript file, and that is going to be piece.cy. And let's go ahead and throw our testing code in there. Okay, and we've got our code inside there. There's a lot more to it here, so I'm going to take this one step at a time. First thing I want to do here is let's go ahead and create our piece.js file. So we're going to do that under classes, new JavaScript file, and we're going to call it piece. And we're going to say export default class piece. And I can't spell class. I am having awful time typing today. So there we go, that gets that finished up. So let's go through and figure out what we want to do, what we're going to be doing with piece. So what we're going to need to do is that although we have just a couple of different things we want to be able to do with, that we initially wanted to do here with our piece, we need to kind of imagine what we could possibly want to do with the piece. So that's basically what this unit test is going to do. We're going first of all, I don't want to do that. We know we do want to create a whole new piece there. So this is going to be, creating the default piece. So I'm going to split a bunch of different tests into a describe block that allows us to do what we want to do for create a default. And also, if we wanted to be able to create another style of piece, I think I should be able to immediately populate the piece with vertices. And so therefore I want to be able to create tests that will test, hey, if I wanted to, instead of just saying new piece, I want to say new piece and then add a vertices, immediately. Well, and that also gets to the point, well, what if I had a piece I wanted to add to it? And for example, if we had, if we could think of in the future, we might want to have some sort of dynamic piece. I should be able to add or subtract vertices as the case may be, and especially if we happen to merge two or more of them together once they make the connection. So we're going to need some sort of add vertex, and that's what this takes care of right here. This is going to be the testing for the add vertex. And I may want to just say add vertex, add vertex, add vertex. I won't be able to possibly do an entire array of them, so I'm going to also have an add vertices method too here. So these are two additional add methods we're going to need. Well, if I want to add a vertex and add vertices, I will definitely need to remove a vertex and remove vertices. So those are two more methods I know I want to do. Well, there's a possibility I won't want to clear off the vertices. When would I want to do that? Well, again, if we're merging two pieces together, one piece is going to survive, one piece is not, so therefore, we need to be able to clear out the vertices since they are unique and make sure that we do our own cleanup here so we don't have any kind of memory problems. So we're going to need some sort of way to clear the vertices out of the piece. Okay, we're going to need some sort of way to be able to know if we have connected if two pieces have connected each other. And this is where we ourselves would define what would make a connection. It could be a connection with just one vertex. You could make a connection for two vertices. If you had a three-dimensional puzzle, you may have a connection for four vertices. Anything like that may be what we need to do. But this is something that's going to be defined at this point and is usually particular to our puzzle itself. This is a merge function. Again, I'm thinking ahead that when I have two pieces that I know are connected, I want to merge them together into a single piece. And instead of actually changing two of the original pieces, which would possibly break the immutability of those pieces, I want to create a whole new piece here. So I've kind of given myself a hint here saying, hey, I want to create a new piece when I do merge the pieces together. And then finally, we're going to need some way to say if a vertex exists. So, and that gives us the ability to say that, hey, I've got a piece here that has 5 vertices, and I got another piece here that has 6 vertices. I want to go through all 5 of these vertices and say, hey, does this vertex exist here? Does this vertex exist in this piece? Does this vertex exist in this piece? Does this vertex exist in the other piece? Does this vertex exist in the other piece? And so on and so forth. As soon as I get to 2 or more, in my particular case, I'm saying, these 2 are connected to each other. So in going through this, these are the functions that I know I'm probably going to need for running the pieces. Okay, when we're creating a new default, we just basically need to make sure that we can actually create it. That it should default to no vertices, because we, if we're going to create a piece, I don't want it to assume any kind of vertices. We should throw the error as the vertices cannot be changed. So if we try to change the vertices, it will throw an error. Again, this is getting back to the immutability issue, and it should throw an error if no property can be no property can be added. That's kind of worded wrong, but basically what that means is that we should be able to throw the error if we try to add a property, and that will basically test everything we want to be able to test with the default. So, for example, here's what we just want to do. We just want to make sure we've created an instance of the piece. We want to make sure that we have the vertex count. So here we now know that we have created a vertex count property on the piece. And what this will do is that if I want this thing to be immutable, the way JavaScript works is that static variables like a string, a number, or a Boolean are immutable. You can't change them. You create new ones as you go along. But objects are mutable. So if I was to sit there and say, if I wanted to give access to my array of vertices within the piece, they can easily go into each individual piece of the array and make changes as much as they want to, and my code won't be able to check that. So I want to try to isolate every property inside the pieces as much as possible. So if they're not going to have access to the array of vertices, how are they going to know how many vertices are there? Well, I'm now going to create a property called vertex count that will tell them exactly how many vertices, and it's going to be returning a static number, something they cannot change. So we're going to throw an error here if we pass if we try to change the vertices property. In this case, I'm just changing it to the letter B. But by doing any kind of change to the vertice property, we should be able to throw the error. And then right here, we should be able to, if we try to, again, add a new property to it, it should throw us an error. And this will allow us to keep that immutability condition always for a particular piece. And that will give us everything we need to do for creating the default. Now let's check what we need to do if we want to pass it with a vertices property, and that vertices property will be an array of vertexes. So basically, just a couple errors here. We should throw the error if it is not an array, or if it's not or if any object within the array is not a vertex object. It should return the correct number of vertices. So if we pass it 3, we should be able to get 3 back out, and it should throw an error if the vertices property, so that the vertices property cannot be changed. So let's take a look at that. So here's the first one here. This will basically allow us to check to see if it is an array or a vertex object. If it's not an array or vertex object, it will kick it on out. No big deal there. This one right here is going to say, hey, if we create a new vertices, we should be able to expect the vertex count, which we created earlier, to be 1. And then finally, in this particular case here, we're going to create some new vertices, and then we try to change the vertices, which we know we shouldn't have been able to do anyway because we don't have access to it. But we're going to change it anyway, just to make we're going to test to make sure we can't do it anyway. In this case, we should not be able to change that, and that will take care of creating a new piece with just the vertices. So now let's take a look at our methods. The first method is going to be add vertex. These are going to be, I'm going to run through these fairly quickly because shouldn't be too much of a problem. Shouldn't be too much of a problem to understand what's going on here, because they all pretty much follow the same pattern. Is that we should be able to throw an error if the argument is not a vertex. As you notice right here, I am passing a vertex as an argument. So if it is not a vertex, then we're going to throw an error. It should throw an error if the vertex is already in the connection. Because if we want to add a vertex, if we want to add a certain vertex in there, and if we want to try to add it again, we should be able to throw an error. Then we should be able to add the vertex to the collection, and we should return the piece. And I want to return the piece when we do the add vertex, in case I want to start chaining, for some reason I want to start chaining different methods together. I'm going to try to return a piece from the add vertex. So how does all this work? Well, it's real easy. This allows us to basically say, hey, can we add a vertex that is not a vertex? No, we shouldn't be able to. Can we add a vertex that was already added? So this is where we add it, and we try to add it in there again. Nope, we shouldn't be able to do that. But we should now finally be able to add the vertex, and our count should be equal to 1. And then finally, we should return the piece, which means we go through all of that and we should be able to say new piece should be back to our original piece. So that should be able to chain our methods together. All right, let's take a look at the add vertices. And that should be real simple here. We should throw an error if it's not an array of vertices. We should throw an error if at least one of the vertices is already in the collection, which means if we're trying to add 5 vertices and vertice number 3 is in the collection, we should throw the error. Given at least one vertices in the collection, should not add any of the vertices. And the reason I want to do this is that let's say we had 3 vertices already inside the piece, and then we add 5 more in there. Now the whole idea is that the entire operation must be successful. So if the first vertex is okay that we're adding in, and the second one's okay, the third one's okay, the fourth one's okay, but the fifth one is bad, I don't want to add the other 4 because the entire operation needs to be correct. So this particular test here will test to make sure that all of the vertices can be added before it actually says, hey, we're all done. And if at least one of them is wrong, none of them get added. Should throw an error if there's duplicate vertices that found the vertex argument. So if I'm trying to add 3 vertices and vertex number 1 and 3 are exactly the same, won't work. Given a duplicate error, it should not add any vertices. Again, if we have duplicate vertices, vertex number 1 and 10 are duplicated, we should not be adding in 2 through 9. Finally, we should be able to add the vertices and we should return the piece. So let's take a quick look at some of these. Take a look at some of these. Yeah, that's what I was trying to say. Very easy here. You know, we shouldn't be able to add vertices if it's not an array. Keep hitting the debug thing here. Okay, we should not be. We've added a vertex here with vertex number 2, and then we're trying to add vertexes with there's vertex 1 and vertex 2. That should also throw the error. Here, this is the exact same error. This is the exact same thing here. We got vertex 2, vertex 1, and vertex 1 and vertex 2 is what we're trying to add back in. That should error out because we already have vertex in there. Our vertex count still should be equal to 1. So what's different with this other one? This other one, we're doing an expectation that we're actually producing an error. That was the whole idea here. But this one, we're actually making sure that we're still set to 1. So that's the difference between those two. Should throw the error if we got duplicate vertices. And there's my duplicate vertices, so we should throw the error there. If there happens to be a duplicate error, then we should not have any addition of any vertexes. So if you can see here, we're adding vertex 1 and vertex 1. If the error actually occurs on the second vertex added in, because that's the duplicate, if we didn't make this check, then this would be equal to 1. And we've added vertex 1, which is incorrect. But what we're checking to make sure is even though we have duplicates, we're not going to add anything in there. Then otherwise we just add it in, so our vertex count should be equal to 2. And then finally we should be able to return the piece. Okay, and that should complete everything for add vertices. Removing the vertex is the exact same thing as adding a vertex, except we go backwards. And our argument is that we're passing it a vertex. So it's basically the exact same thing as we did with adding there. If the argument is not a vertex, we should remove the vertex. We should return the piece. Last one of those slightly different. We should throw an error. The vertex cannot be found in the collection. I'm not going to worry, well, I will worry about that. Let's take a look at those things here. So this is, again, we've gone through this before. That's no big deal here. We're trying to do a remove vertex with a non-vertex argument. We should remove the vertex. So if we have a vertex there, we try to remove it, our count should be down to 0, and that should be correct. We should return the piece. There's the piece. And then finally on this last one here, if we create a new vertex 1 and we try to remove vertex 2, it should give us some sort of error because vertex 2 is not inside of vertex 1. So we want to throw an error if we're trying to remove a vertex that does not exist. And that's all there is to removing vertex. When we remove the vertices, it's the exact same thing as adding the vertices. We should throw an error if it's not an array of vertices. We should remove all the vertices. We should return the piece. We should throw an error if at least one of the vertices cannot be found in the collection. I don't want to remove vertices unless the entire operation is correct, unless the entire operation passes. Exactly the same thing with the add. I didn't want to add all the vertices in there if at least one of the vertices was incorrect. Same thing with remove. Don't want to remove if at least one of the vertices is not inside the collection. If at least One vertex cannot be found. It should not remove any of the vertices, which I just explained. It should throw an error if duplicate vertices are found. And given a duplicate error, it should not remove any of the vertices. So this works exactly the same way as the add one does. So I'm not going to go through the different tests on this particular one, mostly because of time. So that would complete the remove vertices. What about clearing the vertices? Real easy. It's just passing no arguments. So there's nothing checked for us. So we should be able to test to make sure it clears all the vertices. We're passing 2 vertices. We hit clear vertices. We should hit equal to 0. No big deal there. It should return an array of cleared vertices. So basically what this means is I'm going to return the vertices that did get removed. So all I'm doing here is I'm passing vertex 1 and vertex 2. I'm doing clear vertices. I'm returning vertices, so that vertices length should be equal to 2. Technically, I guess I should also test to make sure that they do equal 1 and 2, but if I shouldn't, because I know I'm creating 2 and I should get 2 back, so we should be okay. And this last test tested to make sure that it was actually 0. So that's all there is to clear vertices. Okay, is connected to. Basically it says, is this particular piece, here we go. Is this particular piece connected to this particular piece? So the idea here is we're going to have 2 pieces and just make a simple comparison. Is that connected to allows us to define how many vertices we're going to need to be able to consider 2 particular pieces connected. So let's take a look at the code for each of those. We should throw an error if the second argument is not a piece, of course. We should return false if the 2 pieces are not connected, and we should return an array of vertices if the pieces are connected. So there's where we test to make sure that the argument is definitely a piece. Here's where we test. We added vertex 1 to piece number 1 and vertex 2 to piece number 2. And we should say, and we're going to expect that if we say piece 1 is connected to piece 2, that should be false because they don't have any vertices in common. Down here, same thing. We got vertex 1 being added to piece 1 and vertex 1 and vertex 2 being added to piece 2. Is piece 1 connected to piece 2? Yes, so it should be 1. So in this particular case, we're only doing a one test. Now, in reality, once we get to a puzzle and start defining our puzzles, we're going to probably want to pull this test out of this and put it up into our game section, because our game section is going to be able to determine I want 1 vertex or 2 vertexes or 3 vertexes to be able to define a connected two connected pieces. This one is basically by default saying, hey, if at least 1 vertex connects, 1 vertex connects. And that's all there is to the is connected to. Merging, this is basically saying I've got 2 pieces and I want to merge them together, and that should create 1 piece with all the vertices of those two particular pieces merged together. So what's going to happen is that we're going to throw an error if the second piece is not a piece. Duh. We're basically going to say, let me just go back through this real quick. We're going to basically say I want to take a piece, merge it with the second piece, and return a new piece. And what I also want to do here is that, remember, the pieces are unique. And when I'm merging 2 pieces together, I'm basically saying I've got 2 connected pieces here. So now they're going to act like 1 piece. The original 2 pieces are really not pieces anymore. So I'm going to want to clear out those pieces, clear all the vertices of pieces, and eventually get rid of them. So we should return a new piece if all the vertices are combined. We should clear all the vertices from the first piece, and we should clear all the vertices from the second piece. So real easy here. Here's the same thing we've been doing here. If I pass the wrong argument, it should yell at me. We should return a new piece of all the vertices combined. And so here's vertex 1 and vertex 2 in piece 1. Here's vertex 2 and vertex 3 in piece 2. When we merge them together, the new piece should contain a count of 3. Even though there's duplicates here, that's okay, because remember, we're thinking they're connected. That's the only reason we'd use the merge here. So if we're going to merge them together. If we got duplicates, we're just going to obviously not worry about it, because we can't have duplicates. So in this case, we'll just end up with 3 vertices. And then finally down here, we should clear all the vertices from the, one thing I forgot to say. We should clear all the vertices from the piece. So we're testing piece 1. After we do the merge, we're testing to make sure that piece 1 has no vertices left. And after we clear the piece, after we do the merge here, when we have piece 2, we should check to make sure that piece 2 also has no vertices in it, because all the vertices are now in that new piece, and that does everything we need for a merge. Finally, kind of a little helper is the vertex present, and that basically says that, hey, is this particular vertex right here present inside this piece? So first of all, I should throw an error if there is if the argument is not a vertex, like we have been doing. We should return false if the vertex is not there, and we should return true if the vertex is there. So we know we've been, obviously you're used to that. We've been doing that for every single test here. Here we go. We create a new piece which has no vertices in it, so we're testing is vertex present in 1, and it should not be. And then finally, we're going to create a new piece which has 1 vertex in it. Then we're going to say is vertex present, and we're going to say yep, it is there. And that completes everything we have for the piece itself. Now let's get to the puzzle. I'm going to create a new JavaScript file and call it puzzle.cy. And there's our test for the puzzle. Let's go ahead, as you can see here, it's saying, hey, there's no puzzle.js, so let's go ahead and create the puzzle.js inside of our classes, so it won't give us that funky looking error. So there's puzzle.js, and we'll say export default class puzzle. Save that off. Go to puzzle CY. Let's go ahead and go through this. Here's all of our requirements that we came up with initially for the puzzle. So now we got to try to, we basically got to be able to replicate what we have here, and that's what puzzle.cy does. And also, this also is a point where we need to kind of envision any kind of methods or properties that we might need to be able to perform the all the tasks that a puzzle might do. So this is what I came up with. First of all, we got to be able to create a new puzzle, so that's what the puzzle is there. And as you know, it's just basically create a puzzle. I mean, that's it. So the whole process of the creation here is going to be allow us to create a puzzle. We're going to be able to, I just realized I got an error here. I should be closest pieces. So I want to be able to determine whether I've got closest, if I have a routine that has dropped 2 pieces, I want to be able to determine how that particular, if those 2 pieces, if I've dropped a piece, let me rephrase that, I want to figure out if 2 pieces are close enough to each other to be able to perform a test to make sure that they can be merged. And that will be covered in get closest pieces as a method. I'm going to be able to add a piece, add pieces, remove piece, and remove pieces. Those are going to be real simple. It's just like the add removes that we had on the pieces. I'm sorry, puzzles. Yeah, no, yeah. Add and remove vertexes, excuse me, that we had on the pieces. This one's going to be add and remove pieces. So let's first take a look at the creation. We should be able to create just a simple empty puzzle. We should determine if it is immutable or not, like we have been doing. We should throw an error if the pieces argument is not an array of piece. So there's actually is a pieces argument, which I should have mentioned here. Did I mention? Oh, I did mention it. Okay, cool. I should have expanded my comments there. So I can either do a new puzzle or I can do a new puzzle with pieces in an array. So we should throw an error if the pieces is not an array of pieces. And we should throw an error if there are duplicate pieces, because if we're adding pieces in there, we should not be adding duplicate pieces. And then we should be able to report the correct number of pieces. So let's take a quick look at that. Yep, we should just test to make sure it's there. It should be immutable. How are we going to do that? Well, we're first going to check to make sure that we cannot change the pieces argument or the pieces argument, and we're going to make sure we can't add a particular property in. So that will take care of the immutability. We should throw an error if we don't have an array of pieces, and as you can tell here, we don't have an array of pieces, so we should throw an error. We should throw an error if we have duplicate pieces, which we're trying to add 2 different pieces here to the puzzle, and that should also throw an error. And then finally, we should report the correct number of pieces. So we're trying to create a new puzzle which has 2 pieces, and we're doing a piece count of equal to 2. Because again, everything is immutable, so I don't want to pass the array off to the user. So I'm going to supply them with a piece count property to be equal to 2. So when we write our code, we'll take care of all of that. And that will take care of the puzzles. All right, now we're going to take a look at the get closest pieces, which is going to determine whether they have 2 of the closest pieces together. We should throw an argument if the piece is not a piece. Let's take a look at that thing here. By closest pieces, I should be able to say puzzle, get closest pieces to this particular piece. So I'm going to pass it a piece, and I want to get an array of pieces that are closest to it so that I can then determine. If, like for instance, if you drop a piece and the edges are very close to each other, we will consider those closest. Notice what I've said here. By this routine, by some magic, we'll determine what pieces are closest to another piece, because we don't know what that magic is going to be. So this is something that we're going to have to hook into from the main game itself to be able to say, hey, I'm using this kind of graphical property and I need to determine if two pieces are closest to each other. But we can do some simple things on our own. Like for instance, throw an error if the argument is not a piece, return false if it is not the piece's connection, or return if it's closest pieces. So, you know, again, if the argument is not a piece, then we should throw an error here. Here we find out we should return false if the piece is not in the puzzle collection. This I may have to change a little in a little bit of time, because if you take a look at here, we don't really have a way to be able to determine right now whether the two pieces are closest to each other. So both of these, basically this piece basically will return, if I try to get closest pieces right now, it's going to return false. Here, if I try to get closest pieces, well, I got console.log in there. Huh. That's weird. Okay, well that should disappear. It's gone. So this particular allows us to be able to kind of circumvent the closest pieces routine as we write it. So when we get to the closest piece routine, we're just going to have to try to fudge it for right now until we get to the graphical section of our code. Did that make sense? Of course it did. All right, that's get closest pieces. Now let's take a look at add pieces. Should throw an error if piece is not a piece. Should throw an error if piece is already in the collection. Should add the piece of the collection, or should return the puzzle. Real simple. If it's not a piece, don't do anything about it. If you try to add a piece that is already there, we want to throw an error. We should be able to add the piece to the puzzle, so we should get our piece count equal to 1. And finally, we should be able to return the puzzle itself, so that I can then chain all of these methods together. Same thing I'm going to do to the add pieces, because now I'm going to do an entire array of pieces. So we should throw an error if it is not an array. We should throw an error if at least one piece is already in the collection, because just like with the vectors, the vertices inside of the piece, we don't want to have duplicate pieces inside of the puzzle. So I should throw an error if at least one of the piece, and if one of the pieces is already in the collection. And if one of those pieces are already in the collection, I should not add any pieces. We should add all the pieces and should return the puzzle. Okay, again, argument is wrong, so throw an error. If the piece is already in the puzzle, we should throw an error. So we already got piece 1 inside there, and there's piece 1 right there. So we should throw a range error saying it's not there. Same routine here. Piece 2 and piece 3 are not in the collection, but piece 1 is, so it should throw the error, which we will get here. But once we get the piece count, we should be at 1. So even though it didn't find piece 1 till the end here, we should have piece 2 and piece 3 should not be in the collection. Otherwise, we should have added all the pieces to get a piece count of 3, and we should return the puzzle, and there's the puzzle. And of course, and that should complete add pieces. And for remove piece, exactly the same. Throw the error if the argument's not a piece. Throw the error if the piece is not in the collection. Remove the piece. Return the piece. You know the routines. And I'm not going. You know, I don't have to go through all of this. This is exactly the same as we have with everything else. And it's the exact same thing with remove pieces. You know, we should throw the argument if it is not an array of pieces. We should throw an error if at least one instance is not in the collection. We should. If one instance is not in the collection, it should not remove any piece, or it should remove the pieces and it should return the puzzle. And that's the exact same thing as we did with the vertices inside the piece, and now we're doing within the piece within the puzzle. And that will complete our 3 main unit tests for this particular implementation. And it has absolutely nothing to do with graphics so far. That's going to be step number 2. We'll start working with the graphics. Right now, if we run everything here, everything will blow up. So our next video is going to deal with writing the code to make all of these tests pass, because that's the idea of TDD. We've now written our test to be able to describe what we want to happen. We're going to write our code to be able to pass all the tests, and then we're going to clean up the code to make sure it's all nice and pretty. So once all that is done, then we'll get to the graphical section, which is going to be a whole ballgame and trying to test on its own. But that will complete this video right now. And so next time we'll see you with the code for the puzzle, the pieces, and the vertices. Thank you very much for watching. If you like this video, please click on the like button below. If you wish to keep informed about new content, click on the subscribe button. And as always, please leave a comment below. I'd love to hear from you. Again, thank you very much for watching. This is the Virtuoid, aka Mike Smith. We'll see you later.